The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Welcome to the Oregon ITE SimCap March Luncheon. This time we're doing it all webinar-based with our new home-based realities here. We have a great set of panelists here. We have Amanda Deering from DKS speaking on the Battle of Big Data Platforms. And we have Tammy Lee and Kirsten Tufte speaking from Portland State University on PORTAL, which is the system where we archive a lot of the freeway data throughout the Portland metro region. And then myself, I'm Randy Johnson. I'm one of the SimCap co-chairs for Oregon ITE. My fellow co-chair is Kate Petak with the City of Portland. I'll be finishing up the presentation with a little tips and tricks with applications for Google Maps and Google Earth. Things that we should all know, but I'm finding quite a few people don't actually know. So be very basic level, and then we'll open it up to questions, and hopefully we can have some debate. So we're going to jump right into it. So starting off, this is Amanda Deering with the Battle of the Big Data Platforms.
Thanks, Randy. So some of you may have seen my winter workshop presentation about big data, but I'm hoping to have framed this so that we all learn something new about comparing all the big data options that are out there. With that, I'll get into it and just start off with a brief introduction to the world of big data so that we're all on the same page here. So what am I talking about when we're talking about big data? Generally, we're speaking about passively collected data from devices that emit either GPS signal, Bluetooth signal, or just mobile devices. And this information is collected by third-party vendors and then sold to transportation engineers to provide information on a sample of the population we might be looking at. This graphic just shows the three-step process of how to take a cloud of points that are emitted from a device as you travel along roadways. Each point is called a waypoint, and then how that gets separated into a single trip and then connected to form a route. So that's the basics of what we're talking about today. Next, why do we want to use this big data? Why is it important? So traditionally, our data sources we have collected for a day or a week out of the year at predetermined locations, and then expect this to apply to all transportation analysis we're doing. This data is constantly being collected, so you can get a much broader sense of trends that are happening over time. You can do before and after studies. For instance, if you were interested in how travel patterns have changed during the coronavirus, but oh no, I didn't collect before data because how could you have known? This gives you the opportunity to look at that in more detail. So just noting some of the key transportation measures that we get out of big data. One of the main ones, of course, is origin destination patterns, very hard to collect otherwise. And we can also look at travel time, reliability, variations in vehicle speeds along roadways, and then specific trip routes that people are taking between ODs. So this is a list of 6 key players I'm going to be talking about today. Obviously, this doesn't cover everything. There are many other sources. Some of them focus on different things, like here and TomTom are more focused on the travel time aspect. These 6 DKS evaluated as part of an OD study, so they were primarily focused on origin destination outcomes. But we have Teralytics, manual Bluetooth collection, Airsage, Sidewalk Labs, StreetLight data, and INRIX. So let's get into it. All right, in keeping with my theme, the basic skills we would look for when preparing for battle comparison of these providers would be the resolution of the data, how fine-grained can you get, what sort of sample size are we getting, that can run the range from 1% to 10, 12%, what time period do the data sources cover? Do they also offer travel time and speed? And what is their general cost and turnaround time? In addition, we might also be interested in being able to run unlimited queries, having a good user experience or a platform where we can visualize everything. And then also routing information specifically, and maybe extra traveler attributes such as demographics. So that's what we're looking for this comparison of providers. So battle round 1 with the 6, how do they stack up? Well, a few key points about the first 4. Bluetooth, as you may know if you've used it before, the manual collection can be very hard to scale. You have to set your sensors up ahead of time. They have to be predetermined along the corridors you're interested in. And you may also have limited data periods for when you collect it. For sidewalk labs, it's a bit of an unusual animal in that they actually build specific models for cities or project applications. So there's a lot of model data going on. It takes a long time to put together and may not be the right fit for every project. Airsage is one of the first pioneers in this area. They've done OD for a long time. One of the big downfalls is the lack of user interface and the ability to requery the data. Basically, you send in your request for the data and the zones you're interested in, and then they return the data to you in spreadsheet format. Teralytics is another new provider on the scene. They have a good user interface and would be very good for regional studies. However, the one downfall is they are primarily reliant on cell tower location because they use mobile device data. So they have limited location precision, which might be okay if you're doing a region-wide study, but if you care about detailed circulation studies, that might not give you the detail you need. So you may notice I didn't mention 2 of the providers in my last slide, and that's because they are the winners of this first round. So INRIX, specifically the INRIX TRIPS product, DKS has used this product along with Moonshadow's DB4 IoT platform, which stands for the database for the Internet of Things, which is very long to say out loud. So the reason these 2 come out as winners is the INRIX TRIPS has GPS data, which generally has a good sample and precision. Specifically with this product, we're able to run unlimited queries on the data set that we purchased. And it also has very detailed routing information because you're basically getting the raw data from INRIX. So that checked all the boxes. And then for StreetLight data, it has a polished user interface, and its data sources are GPS and location-based services, so data that comes from cell phone applications. And the GPS source is actually from INRIX. So these 2 sources use similar raw data. It's just a matter of how it is cleaned and presented. The one benefit of having the LBS data from StreetLight is that it provides traveler attributes such as demographic data. And then in StreetLight data, typically queries are based on the number of zones that you're looking at. So you draw geographic areas. That is what your queries are based off of. And then finally, StreetLight data also has the potential to visualize specific routes between origins and destinations in its platform. So those are the first 2 winners of round 1. And now I'm going to take a little bit of a deeper dive into these 2, since as you get into the big data world, these are the 2 you might see the most, so you know what to expect. So to go over some basics, INRIX TRIPS, generally you purchase data, or so a selection of trips by population or area. That's how it's priced, and that's how they pull out a selection of trips. Generally, you have about 6 to 12 months access on the platform, again, through Moonshadow, which is a third-party company. And then a key benefit here is once you have the data, you can run unlimited queries in the platform. So if you have a 12-month sample, you can split that up however you want and draw as many zones as you want. One potential downfall is data cleaning is dependent on the user. You are getting raw GPS data. So there are some anomalies. There are some trips that maybe they look like they went into the river or they stopped somewhere you wouldn't think they would stop. And all of that is dependent on the user in this case, which means when you're doing your queries, you have to make sure you have an adequate sample and that the results are reasonable. StreetLight data, the way they're set up currently is you purchase by a number of zones. So they have buckets like 0 to 10, 10 to 50, etc. And you decide, I think my project is going to need 25 zones. So that's how you purchase the data. Generally, you get 1 year access to their platform. You are allowed as many queries you want with your pre-purchased number of zones. And a big benefit here is that StreetLight actually does a large amount of the data cleaning. So everything is reported back to you either as a StreetLight index or as a traffic volume. So they go through and make sure things are statistically reported so that you know the sample size and your zones are drawn so that you will not report data that has not been fully cleaned. So moving on from those basics, I wanted to give a little preview of what working in the platform looks like, because honestly, we could go through all the technical details in the world, but if working in the platform isn't easy and not able to understand, then really it loses a lot of value. So starting off with the platform we used for INRIX trips, this is a snapshot of what it looks like. The mapping is in the middle. You can color the dots by whatever you want. In this case, they're colored by speed. The querying options are on the side. There are filters, there are charts that you can pop up so it instantly refreshes with whatever filters you were applying, which is very helpful to help check the different queries you might be downloading. In addition, you can pop up charts or tables in the window, and then of course you can download all this data to CSV files. So there are a variety of tools here. The biggest benefit is to be able to see all the raw data yourself as you're querying it, so you can really double check if it's making sense. In contrast, the StreetLight user experience, this is a snapshot of their visualization. So after you go through and set up your query, it steps you through very nicely. You come to the visualization stage. And here, you'll notice you don't see all the dots and waypoints. It is much more polished and summarized. So you have the zones. It's being visualized here are ramps on and off of 205. And then you have your filters on the left side, so you can filter by time of day or by a specific origin or day of the week. And then the resulting origin and destination volumes show up on the right-hand side. So in this case, the visuals aren't quite as striking because you don't see the routes here, but it presents all the same information. StreetLight also has an option to display routes, which I will talk about later. But this gives you just a snapshot image of what the two platforms look like when you get to working with them. So let's get into round two, comparing these two providers. So here I've listed 4 pros and cons for each one, pros being bolded. So I've kind of mentioned these before, but basically with INRIX, you get the raw and processed data, which means you can see fully detailed routes and you have more control over running any query you want. However, more technical knowledge is required to make sure you're interpreting all the answers correctly. StreetLight data, I would say, is more user-friendly. It even has options to give you volume data instead of just a sample, which can be very useful for clients to be able to understand the patterns with real volume data. And They do allow you to run multiple queries, but obviously that's limited by the number of zones you've purchased. So beyond that, a common question is usually the cost. For both of these, the minimum fee can range from $6,000 to $12,000. I would say generally the INRIX trips, because of the purchasing of the data and the platform, has a higher starting threshold, closer to that $12K for smaller studies. StreetLight data has lower cost for smaller studies, starting at $6K, depending on what capabilities you want. But as your projects get bigger, the INRIX data becomes more cost efficient. So it kind of depends on the project, but that's just kind of some background knowledge of where we're starting from with price. Setup time, both of these are pretty quick. If you already have a StreetLight account, the data is all there. You just have to send through a purchase order, whereas with INRIX, you have to allow them a couple days to get the data selected and processed into the platform. But either way, we're talking like a week at most of turnaround time. So normally this data is available pretty quickly. So who is the winner between these two? Well, you might be able to tell from the way I'm talking about them that it really does depend. It depends what specifically you want for your study. Do you want that specific routing detail? Would you be more interested in having demographics, which StreetLight provides? Do you know how many zones you're going to want ahead of time? Because that's another big thing if you want more freedom in exploring the data. And then, of course, like I mentioned, the cost, because that changes based on which one you're looking at. And besides this, these products are constantly evolving. So it's really important to always double check the price and what capabilities come out of them, because I think had I done this presentation a year ago, there would have been a clear winner, but today I think they're on pretty even footing. So in order to show you that, yes, indeed, both of these are winners in my book, we're going to go through 3 project applications that DKS has worked on with these. The first one is an example with StreetLight. So on the right, this is an example of the zones I set up. This is the Donald Aurora interchange along I-5. You're doing an interchange design study here, and there is a lot of activity just off the ramps with a truck stop and some commercial uses. So this OD data was used to support the design of the interchange, help us understand what were the travel patterns using this interchange. Are they coming from the local services? Are they coming from Eland Road, east and west? Where are the demands throughout the day? Because again, we can sort by PM peak hour and AM peak hour. We also use the OD data as an input for the traffic modeling. And a big bonus of using this data set was that we could look at freight rate data separately. So there was a big truck stop, and obviously freight patterns are different than the vehicle patterns. So we were able to separate that out and look at the OD matrix for this area. So that's the first example. The second example is with the INRIX trips in the Moonshadow platform. This was a circulation study we did for a neighborhood in the Southwest for Southwest Corridor, the light rail project. Basically, with the build projects, there were going to be some access changes to these neighborhoods. And even today, there are some cut-through issues and diversion issues for the neighborhoods, as you can see here. This is looking at a specific OD pattern going northbound on Barber to the Ross Island Bridge. How do people travel today in the PM peak hour? You can see that some people do go through the neighborhoods. So we looked at the INRIX platform. On the left is a snapshot of what I got out of the platform, and on the right is an image summarizing that information in a bit cleaner way. It demonstrates how cleaning of the data is necessary. So for this project, we looked at various different origin destination combinations to determine what cut-through routes were likely in the future and which ones would go away with the future build. So that was that example. And then last but not least, I have definitely talked about this project before, and I mentioned it in my winter workshop presentation. But just as a quick overview, we did an an OD study for the Southwest Washington MPO, which is RTC, and they were looking at patterns in all of Clark County. Specifically, we were focused on the 4 freeway corridors, but the data covered any trips that passed through or touched Clark County. So we were able to look at region-wide patterns, either using the I-5 bridge, the I-205 bridge, which on and on ramps were used the most, where auxiliary lanes might be helpful. A lot of questions. So this was a case where we really needed that exploratory analysis to be able to see what was going on. And instead of talking more about this project, I am going to do a quick little comparison, because in most cases you can't directly compare apples to apples for these. But in this case, we used our StreetLight marketing and research subscription to compare the outcomes of these 2 studies, or at least 2 of the applications that we used. So on the left, you see what StreetLight's routing platform looks like, and on the right, you see the INRIX DB4IoT platform. These are both showing the same thing. It's looking at diversion off of I-5 southbound from the Main Street ramp headed into downtown Vancouver. So looking at everyone who gets off here, where are they going? Because yes, a lot of them do go down into downtown Vancouver, but a lot of them are just cutting through to get back onto the freeways, you can see here. So both of these platforms showed the same thing, but you can kind of get an idea of the 2 visual differences between them. Then my second comparison is specifically looking at the numbers. So looking at OD from ramp to ramp, this is looking at I-205 northbound on the Clark County side. So 2 snippets of what querying the databases might look like in both StreetLight and INRIX. And then a comparison of the actual percent OD distribution. That's what's on this right side, is a comparison between the 2, showing the difference in the OD patterns. And the specific numbers aren't as important as just seeing kind of the scale that it can vary at. So while these platforms are often using some of the same input sources, and you may be running similar queries, it was good to know that there is a little bit of variation, although generally this query came out pretty close, I would say, all things considered. You're looking at, plus or minus 5, maybe 10% difference. So that gives a really good insight on kind of the level of accuracy and detail of what we can expect out of these platforms. And I would love to spend more time comparing them, but this project offered a good opportunity to at least look at how the 2 options compare. So there are many more options and many more projects that we can apply this to. Those were just 3 quick ones to talk about how you figure out which platform is best for your application. And with that, I'm going to briefly go over some key takeaways, because I think I'm just about at time. So the key things I would want you to take away from this is that in the beginning, know what questions you want answered, because that's going to make a difference in what studies and providers you're going to go with. So thinking about if it's an OD study, if you care about specific diversion analysis, do you also want travel times, or is that not big of a deal? Second, know your data limitations. As with all sources, this data has its limitations. You have to know the amount of precision you're actually going to get from it. Know the difference between presenting samples versus total volume. That's an easy one for us to forget for traffic engineers who are so used to looking at ground truth volumes all the time. And then, of course, user interface, I think, makes a huge difference in what platform and providers work the best. 3 speaks to always comparing the most current information before you make a purchase. The cost structures have changed several times, even within the last year that I've been working on these projects. And the size and scale of your project will determine which one you want to go with. So it's always a good idea to get a quote from look into multiple vendors before you decide. It's not always one or the other when it comes to StreetLight and INRIX, or maybe one of the other 4 I talked about would be a good fit for you. And then 4th, just always use good judgment when you're working with this data. I think it's easy to forget that we still need to use our data analyst skills and double check if you find something that looks suspicious. Because yes, maybe there's a pattern you didn't know about, but maybe you're not quite interpreting the query you're asking correctly. So with that, those are my key takeaways. I hope you at least learned something new about the big data sources and all the ways that we can apply them. So that's all for me. Back to you, Randy.
Alrighty, well, thank you very much, Amanda. It's certainly great to see these types of applications. There's certainly even more data providers out there, either directly on the data side or on the processing side. And it seems like there's more and more applications coming up all the time. And I think that's an important point that you hit on, is to always check to see what's the latest and greatest with your particular data provider before you go down the path of procuring that data. Because yeah, from when I first started using StreetLight 4 more years ago, yeah, it's changed dramatically, and always for the better. So definitely always make sure you're up to the latest and greatest. And I think these companies like to see applications, and they may not be on the same line of thinking that we are. And so, you know, as an industry, we could certainly be pushing them as well to come up with new ways to look at the data, and new ways we could sort of use this to support the transportation industry. So it looks like we have one question here. It says in the INRIX StreetLight.
There's one question.
What's that, Maggie?
Go ahead. Oh, I was talking about the question since you're reading, so you can go ahead.
Okay. So if anybody has questions, there is a questions function. Feel free to post any questions that you have. We'll try to answer it. There will be another opportunity at the very end to answer any questions. Also, with a typical SimCap luncheon, this is a what we normally do is we're all in a room eating and talking, and we try to keep it a sort of fairly interactive roundtable type presentation. But given that we have everybody online and actually quite a large group, it looks like about 75 attendees across the country right now, it's a little hard to just unmute the mic. So even if you don't have a question, if you just want to share a particular application or source that you like to use, feel free to just add information in the chat window as well. So we'll answer these 2 questions here, and then we'll jump on to our next presenter. So first question is, yeah.
Hey, I just want to say for the last part of this webinar, we can have people raise their hand, and if they want to talk, we can open that up.
Okay, great.
Yep.
So first question for Amanda is, in the INRIX StreetLight comparison, StreetLight expands to the full population. Was the INRIX data expanded or raw percentages?
So I assume that's talking about maybe this one. So in this comparison that we did, I wanted them to be as apples to apples as possible. So I did just report the index, which is StreetLight's equivalent of a sample, for this OD comparison. So both of these were sample comparisons, not full volume comparisons. And then I calculated the percentages individually and compared them. I was trying to do the most apples to apples possible, but the volume is also a newer feature in StreetLight, so I haven't had a full chance to explore all the possible applications and ground truth it as much. But yeah, in this case, I was just using the sample size to compare.
Okay, thank you. So the other question was about the slides. So this presentation is being recorded, and we'll see either about getting the presentation posted to the OregonITE.org website or getting the slides posted. Alrighty, so next up, we have the latest and greatest with PSU's portal. I'm going to make Tammy Lee the presenter. All right, Tammy, you should now have the screen. You'll have to share. There you go.
Can everybody hear me all right?
We can. It's all yours.
Okay, awesome. So I'm Tammy. Thanks for the opportunity to present what's new with Portal. I'm just going to go through some data sources, user tools, and some basic visualizations we were able to do with looking at traffic trends since COVID-19 was detected in Oregon. The Portal team consists of myself, Kristen Tufte, and our graduate students, Bassem, Utsav, and Will. They provide a lot of help and assistance in making sure that Portal runs pretty smoothly. We also want to thank all our partners and our funding sources. And if there is a partner or agency that's not listed below, I'm really sorry. Please send us your logo so we can add that. Next. So what is Portal? Portal is a mobile transportation data archive for the Portland, Vancouver, Hillsborough metropolitan area. A lot of the data that's in Portal is used for the production of regional performance measures, research, and particularly a lot of researchers at PSU will use data out of Portal, in addition to using it as sort of educational opportunities, learning how to use traffic data, get familiar with the types of data that are available out there. And in particular, Portal, the data that is included is listed below. We have highway data, incident, vehicle length, transit, arterial, and weather as well. All this data is publicly available, and any of the sort of calculations or methods that are used for the calculations that are featured on some of the pages are open and publicly available as well. We have a documentation website that goes along with how to use Portal, in addition to how some of the calculations such as travel time or vehicle length have been implemented. So unlike some other data sources out there, this is entirely open and available. So if you go to the Portal website, this is the page that you see first, and you can see in the upper area there is a menu bar with that it shows the different options that you have for looking and exploring some of the data. And in addition to that, we have two maps that are available. On the left, it's the live traffic speeds, and on the right, it's the 15-minute average speed over the last 5 days. So I'm only going to focus on travel time and the vehicle length page. Feel free to go to the website at your leisure and check out everything else that we have available. So let's see, on the travel time page, this is what you'll see when you click on that option on the menu bar. You'll see that you have route start week, reliability weeks, the option to aggregate, and then all the stations that are available. So there are really two ways to use the travel time page. So you can either select a route, a predetermined route on the right side, and in addition to that, you can also click on the different points to build your route that you're interested in. And a blue star will appear after you click on your first point, which tells you the available directions for that particular route. So you can only go, if you're going westbound, you can only go westbound, and it shows the westbound stations available on the route. There's no way you can, travel eastbound, westbound. And in addition to that, just want to point out on each of the Portal pages, you can either take a tour, and you can press the tour button, and it'll demonstrate how to use the different features on the website. In addition, in some cases, we have a little eye icon that will provide additional information in case you're curious as to what does the route mean or how does the start week work. So in this case, the start week is as of March 29th, and it goes back 4 weeks. So once you click on the update button after you've selected your route, you will see this figure will be generated below, and it will show you the weekly travel time for each week. And you can also scroll over the different points on the figure, and it'll show additional information on a pop-up. In addition to that, there are these other two options on the travel time page. So here we have the add and remove reliability data. And when you click on that, it shows the reliability data in green, which is the 80% travel time for past 26 weeks. Here in this case, just want to also point out that in the legend, you can turn the different data points on and off if you choose to. In this case, only the week of March 22nd and the 80% travel time has been selected. In addition, we have the option to add and remove sample count data. So if you're curious as to how the reliability data was calculated and how good the data is, you can click on that. And in this case, we only have the sample. I've only selected the sample count for the week of March 22nd. You have green and red. Green means it's good. You have over 30 samples listed, as you can see on the right side on the axis where it says sample count. Anything less than that is, should be taken with a grain of salt and how you want to interpret that data. Next, just want to show you some stuff for the vehicle length page. Here, if you click on the vehicle length option on the top menu bar, this is what you'll see. And you'll see all the different stations that are available that have vehicle length data. We have stuff from ODOT as well as WSDOT. And in this case, you can either select a station by using the drop-down menu if you know exactly where you want to go, or if you're curious as to a certain station along a certain route, you can also click on a option or a station along the map. And in that case, when you click on the station on the map, you have a pop-up and it shows a little bit of the metadata. And then you also have the option to do a start and end date, as well as measure for volume. And then you can also pick your resolution in terms of 1 day or hourly, and then standard or aggregate. And then once you click the update button, you have the option to, the data that you've chosen has been plotted. Again, the plots on the legend, you can click those and turn them on and off. And another feature is that you can select along the plot to focus in or just provide additional data. So in this case, this was 1 day, but if you had decided to choose a month's worth of data and you're really interested in one particular week, you can select a week, and then it'll just zoom in on that particular timeline. And then you also have an option to reset the zoom if you wanted to. So those are just a quick snapshot of what's available and how you can use some of the tools that are available on Portal. A lot of people tend to use the stations page as well as the highway page. Please feel free to look over those different resources as well. We have a downloads page, and in that case, you can download all the data that's found on any of the other pages. You can download based on location. You can download based on the highway that you're interested, the different metrics that you're interested as well, and also the resolution. There's some extra data available on the downloads page, such as the metadata that you might want for the different detectors, stations, and highways. And we also have some quarterly transit data from TriMet that's also available. The other pages that we didn't really go into include the arterial and arterial signal. And also there's some additional data that's available in Portal, which includes the incident data, VMS and VAS. That data is in Portal and can be publicly requested from us. It's just not available on the website because we don't have a UI developed for that yet. We also have a documentation site. That option is on the top menu bar as well. And the documentation site pretty much tells you how to go through each page, how to use the different features, and then also, any definitions or calculations that you're interested in, how they were done. And on the documentation side, we have a specific page dedicated to the Portal users group. Some of you might be familiar with it. It's a group that meets every third Wednesday, and in that case, we tend to talk about any new or updated issues or features for Portal, but a lot of the focus is on presentations from other transportation interested people. It gives an opportunity for people to present some of their research or projects that they're working on. Most recently, we had Maggie present on some work that she did using ATS-PM, and also Allison Tanaka gave a presentation on how City of Portland is using ATS-PM data as well. And in that case, through the Portal user group page on the documentation site, we always post all the slides that were presented. So check that website out as well. Some upcoming projects for Portal include API documentation. There was an interest and need from some Portal users that would appreciate having some API documentation so they could not have to always click through Portal's website, but just be able to write some code and be able to grab some data. Another project that we're working on right now is working on travel time calculations across agencies. So currently on the travel time page, you can only select stations within a specific agency. So you couldn't really necessarily cross the I-5 bridge going from ODOT to WashDOT stations at the moment. But in the next couple of months, we should be able to at least be able to calculate travel time page that crosses that particular boundary. We're also doing some work with biped Portal as well. So that should be up and running pretty shortly. And then that houses all the bicycle and pedestrian data. And then in addition to that, we're always looking and adding potential new data sources, as well as adding data from new stations that are being installed. We are also working towards developing a transit page and adding some improvements to the arterial page as well. So I guess a lot of people have been interested in sort of the transportation trends since the detection of COVID-19. But the data that was used to produce all the figures I'll be showing were data that were just taken off Portal's website. I made it a point to just show how useful and easy it is to download data from Portal. We have some instances where people might want to get data from us that's at a finer grain resolution, or want more data across multiple years or months. And in that case, yes, you can make that request and we'll fulfill it and provide that data for you. But in the interest of some people who are just interested in getting a quick snapshot or just wanting to explore some of the data that's available out there, you can easily do something similar to the work that's going to be presented shortly. So a couple of key dates to maybe be reminded of as we look through these plots. So February 28th was the first positive case of COVID-19. And if I'm incorrect on any of these dates, please let me know so I can fix it later. But these are all taken off different news websites. So, and then March 12th was the close of all K through 12 schools and a moratorium on gatherings of more than 250 people. March 15th, temporary shutdown of restaurants, pubs, and entertainment facilities. March 16th, moratorium on gatherings, there were 25 people, and then March 23rd was sort of the stay-at-home directive. And so the sort of closing down of large gatherings started to begin around March 12th. So that's a pretty good sort of date to keep in mind. So I just picked looking at highway or I-5 northbound and just looking at the mean daily volume on I-5 northbound and how it's changed over time. So these are just mean daily volume showing since February 1st up until Sunday of this past week. And it's grouped by the days of the week, so you can do the comparison of Saturday to Saturday, Sunday to Sunday, so it makes it a little bit easier. So you can sort of see how there's like traffic in February, and then towards like right around March 15th, we sort of start seeing a sort of downward trend of mean daily volume on I-5 northbound. And then the subsequent figures I'll be showing, I'm looking at a comparison between everything that's happened beginning of March, and the week that was used was February 22nd. So the transportation, so you can see in this page, this figure, it's the percent change in average daily volume on I-5 northbound, and using February 22nd as a reference week. And if you had watched the INRIX webinar last week, they had used February 22nd as a sort of a reference week. So for some sort of comparability, if you had seen that webinar, I'm using the same week, so you can get an idea of how that applies or compares with Oregon. So the week of March 2nd and March 9th, it's a little bit, you have increase in daily volume traffic, and then really beginning around March 12th, 13th, you sort where the orange vertical line is, you sort of start seeing a decline in average daily volume on I-5 northbound. So this is in comparison with the numbers that were published on INRIX's blog about looking at the effects of coronavirus. So on the top is sort of that national comparison for the weeks up until March 20th. And so you can see the nation was already seeing some decrease in total traffic. And then here's New York. In the middle is Portland, and then below is San Francisco and Seattle. And really the beginning of sort of shutting down large gatherings really didn't start until like around March 12th, 13th. So the response to that might be slightly delayed compared to other locations where their first instance of a positive test case might have happened earlier. And then, let's see, this is an example of looking at some trends in vehicle length data. So on the top, you have the 0 to 20 feet vehicle length, so like personal vehicles, all the way down to 60 to 120 feet length of vehicles, and that's sort of like your long haul commercial trucks. And so you can sort of see on a snapshot like, oh, okay, absolute daily volumes, you can sort of see how there's sort of a downward trend in personal vehicles, and then maybe a little bit of a uptick in commercial vehicles. So to get a better idea, we looked at using the week of March 22nd. We did some comparison as a reference week to see the percentage change. And here you can see the orange line again is sort of that week of when people started, or when those orders were issued. And then after that, you can see how definitely the use of personal vehicles has gone down. And then you can see an increase in the movement of long haul commercial vehicles, which is interesting because it implies that maybe our Supply chain is still okay, and the movements of goods are still fine. In addition to looking at just some traffic, some vehicle and stuff, we also looked at to see what habits people have been changing, especially in the Portland area. A lot of people like to ride their bikes. And so here we have the northbound or north side Hawthorne Bridge, south side Hawthorne Bridge, and then Telecom north side and Telecom south side. You can sort of see how ridership has been declining slightly a little bit. So we also looked at sort of the percent change using the week of February 22nd as a reference week. So here I'm only showing Hawthorne north side and Telecom north side, since they look pretty similar in the other figure. And so you can see the daily change in bike ped volume, and you can see on the weekends it's pretty high, and on March 22nd that might be due to like really nice weather and the last really nice day in Portland. But then you definitely see a sort of decrease over time of some of the of crossing over the bridges as the time goes by. So whether or not this is due to weather or due to those policy effects remains to be seen. A couple more weeks of data might be helpful in addition to doing some actual statistical analyses. So that's basically the end of the what I have to present. The data that's presented in the figures, they're just quick snapshots. We haven't done any sort of statistical analyses on them, so just take it with a grain of salt. And so the portal website is listed. If you have any questions, comments, concerns, anything about portal, or you're just interested in data or getting more data, our contact info is listed, and as well as the documentation site website URL is listed as well. That has a lot of helpful resources. And then if you're more interested in what comes out of the data that was presented, we'll be presenting some more information, and will be posted through Trek. So just if you visit that page in a week or two, there'll probably be some updates. So, any questions?
All right, thank you, Tammy. We do have one question here. It said, even though schools were closed, may spring break account for a drop or increase in travel during the March 16th to 20th time frame?
Oh, let's see. That could be also due. Yeah, I mean, surely spring break could also be an effect. One of the things that we haven't looked at or haven't had time would be to do an actual comparison for this time last year. That's something that we're also probably going to look into. Just haven't had time.
Yeah, and that's an interesting question, and there's so many factors, I think, given the times we're in right now. So I know particularly during that week, a lot of my friends and colleagues ended up having to cancel their plans because of either hotels closing, but I know a fair amount of folks that still went out and about as well. So there's probably a little bit of both. Just like in the early days, I think there was some folks who maybe quit riding transit and started driving in, but at the same time you had some telecommuters. So traffic volumes may have had some mode shift differences, but it's just hard to sort all that data out. But going forward, it's certainly going to be interesting to keep digging through this data, figuring out, how long is this trend going to last? What are the economic implications coming out of this? And then are we all going to figure out that we love working from home and we don't need to be in the office and we can do our job just as effectively and none of us are going to commute anymore? That's certainly a question on what telecommuting is going to play in the future, and are we going to see a benefit from traffic just from that regard? So I don't know that anybody knows at this point, but those will all certainly be interesting questions, and we'll be looking at a variety of these data sources moving forward.
Yeah, I mean, like all the data that's presented in Portal, you can easily, like anyone could just go and download data and try to, play with it and do some analysis to see as well. So,
Great.
Yeah.
Alrighty, well, thank you again, Tammy. And I'd also like to thank Kristen Tufte for helping put together the presentation here. So I'm going to take back control of the screen here. All right, again, any questions that come up, feel free to add those in either the chat or the question box. So what I'm going to present on here, this was originally going to be just kind of to seed a roundtable discussion on what folks use for different quick and cheap data sources. Given our limited ability to do that, I'll just kind of run through a few tips and tricks. And so while the big data sources are great, some of them require that the analyst have some data analytics skills. Sometimes there are some programming skills, or you need to know how to use the tool sets. Often there's a cost. And I know a lot of us simply use Google Maps and Google Traffic for just quick planning level estimates, or even looking at, what are conditions right now, or using the Google typical traffic. So there's a few features, tips, and tricks that I frequently use that I'm still surprised that I come across folks who are unaware of these features. So we have a pretty good panel here, and hopefully most of the folks are aware of these features, but I thought I'd cruise through these and see. If you don't already know that these exist, this will be helpful for you. So plain old Google Maps here, when you open it up, it's often in 3D or globe view, which is great. You could pan and tilt and look at it in 3D, but often the case is the 3D mode or globe mode is not the latest aerial. And so if you go into the menu here in the upper left, you could turn off that globe view. And again, not all the case, sometimes they're on the same, but often you'll get a newer aerial. In this case, there's a construction of a new school in place and some road changes that you're able to see. So sometimes turning that globe on and off is certainly a helpful feature. You can't go back in time on Google Maps, but if you jump over to Google Earth, I guess one thing to point out is Google Earth doesn't have the same 3D display that Google Maps does, where it's kind of pre-rendered by Google. And in this case, the latest aerial is the one showing the newer construction. So I've even seen it in cases where the two displays in Google Maps and Google Earth are even different. So it varies by location and what Google uploads, but just be aware that you have those different options and don't always assume the default Google Maps will give you the latest and greatest aerial. If you're also not aware, you can go back in time in Google Earth. There's this historical imagery button here on the top, the little clock with the back arrow. And you could basically go through time, depending on where you are, depending on how far back they have aerial imagery. It's always fun to kind of go back and see how things have developed over time. And in most larger urban centers, you could actually go back quite a ways. And, pre-freeway Portland here is always interesting to take a look at and to see at all the blocks. Pre-waterfront park, seeing the Harbor Freeway right along the edge of the structure. So being a traffic nerd and a history nerd, this feature really, really connects with me. So that's the aerial imagery. When we start talking about Street View, you do have Street View available in Google Earth, and you can drop in any location. But when you drop into Street View, into the park here, not the best image, there's no way to go and adjust which Street View image you're looking at. But in Google Maps, if you drop in any location, let me get more into town here. And again, I happen to land in a park, but you get a time slider if you go to the upper left here. Let me grab a location that's more busy here. And so you can click this down button, and often you'll get multiple time frames. So here you go, this particular spot, you have quite a few different times that you could go back and look. Pre-streetcar. So this is sometimes helpful. Sometimes you could be using this to look at where detector locations are. Sometimes if you want to see what signal phasing is, because sometimes if you don't have the signal timing sheet or you don't have the ability to go out in the field, sometimes you can catch whether or not a left turn is permissive or not by using Street View. So the historic Street View is certainly a helpful tool. So then a feature I think a lot of us use is the Google Traffic. So when you go into the Google Maps menu, you can turn on traffic. Most folks these days are well aware. And in our current home-based reality, we can see everything's green, nearly everything. But then we have the feature down here. So if you don't want to see what the current traffic is, you could go to the typical traffic. And then you get to the time slider. You can choose the time of day as well as a day of the week. Now, personally, one thing I'm really curious about is I don't know how Google calculates this. It's likely some sort of rolling history of data, and I'm just hoping that the COVID times don't get wrapped into this typical traffic, just because the next several months, if we're still doing our planning projects and we want to know what peak conditions were pre-COVID, this is one of the few tools we have, unless we go the big data route and start pulling INRIX data. So hopefully Google will keep that pre-COVID data separate, but we'll see. And then you could also grab travel times. So if you grab a travel time between one section and another, it'll tell you what the live travel time is for the top 3 routes. So this is a handy feature if you want to pull any condition of what it is now and the fact that it automatically does the top 3 routes. But you could also use the typical here. And when you do the typical, say depart at, let's go AM peak. So if we depart at right in the morning peak, we see it'll give a range. The low end of the range is usually your free flow condition, and the upper end of the range is generally the typical congested condition. So you could get a sense of, well, what is it like off peak versus peak for these routes? The one thing that I like to use, you could even adjust the route. So you could grab a route, and if you hold and drag, if you want to take another route, you can get it to choose one particular route, and then it'll choose that for you. So one thing that we often use these for is when we go out and say we're doing a modeling project, whether it's vSim or Dynamic or some other tool, we'll go out and we'll collect a whole bunch of data. Maybe it's travel time data, Bluetooth data, traffic counts. We'll do our field observations, looking at queues. And one thing I like to get is the live traffic data every 15 minutes from Google, saved in a snapshot, so that I have a record of what was the live condition like on the day that we were out in the field collecting the data. Because that's ultimately the data that you're going to be calibrating your model to. And sometimes that's not the same as the Google typical traffic, or when the person who's reviewing your model is familiar with that 90th percentile case and they have experienced sort of the worst of the quarter, but that's not what it was like on the day that you collected all of your data. It's nice to have that Google Maps every 15 minutes. So one tool that you could use to do that, there's different online tools available. One that we've used is called BLIT app, B-L-I-T app. And it's just simply an online website that does screen grabs. There is on this particular one a low cost, but it's certainly cheaper than paying an intern to take screenshots every 15 minutes or having someone in your office do programming through the Google API to pull out this data. So this is something that anybody could do with any skill set. So all you simply do is create a project, and you grab the link. So if this is the route that I wanted to record live, I simply just copy the link out of the browser, paste it in here, and then I could set up a schedule. And so it'll do this over multiple days. It'll save all of the images to a cloud. You have the ability to go through and automatically crop the images, set what the resolution is going to be. You could save it to other cloud app services, so it's not saving to an email. But basically, you just get a big archive of all these images, which you could then either be the live traffic, it could be a particular route, and in those images, you're going to get the travel time and how that changes for each 15 minutes. So just kind of a quick example of how we've used that. So in this case here, a project where, again, we grabbed a segment, we put a route, that information is all saved in the Google link, and then we can see every 15 minutes how that travel time changes. We can compare that to Google Maps, and we can see how traffic builds and dissipates for that particular day. And so this is something that it doesn't really take much effort to set up. It creates a nice archive for your particular project. Again, it's all free, low cost. We could basically do the same exact thing using congestion plots out of, this is from a vSim microsimulation model. So it's always helpful to compare the congestion on the same scale and resolution that you're pulling the data from Google. So something that you could dump into the appendix of a report. And then you could use it for any tool. So another, if you just want a comparison's sake, you could pull up the Waze live map. And so similar to Google, you could put in from and to times. You could either have the live travel time, or you can choose a depart at, and it'll give you similar ranges. And they'll give you the top 3 route times as well. So you can see here the difference between routes 1, 2, and 3. And so you could use a tool like Blit to go through and archive similar data. But it's always nice to have that backup of data done from when you were out there in the field. Of course, I would say also field verify. So when you see that red line on Google Maps, is that consistent with what you're seeing in the field? And it's always helpful that maybe get some images to back that up. So the last little tip and trick here is on the path for you can use the distance measuring tool to actually pull a grade or elevation. So if you choose the path file here and check this box, show elevation profile, if you need to just approximate what the slope of a particular facility is, maybe you're putting it into a vSim model to get the grade for impacting the trucks, you could run that elevation profile if you, again, just need that quick and dirty. So you're coming out of the canyon, you can see that average about 4% climbing. And you can see as I move along the map here, you can see kind of what the elevation and what that grade is. So that's my quick and easy overview of using Google Maps for basic traffic engineering and planning. Hopefully most of you already knew those features. If not, hopefully that's something that you can take away from this presentation. Let's see. Looks like we do have one question here. Can you cover the comparison of Google travel time grabs versus doing IPEMS or RITIS historic travel time analysis? We have done comparisons, and I would say it's different for every corridor. We've used TomTom travel time data. We've used INRIX, some of the portal travel time. And generally you're within, say you're on a 10-minute segment, you're gonna be within a minute or two of those. So all the data sources, there's gonna be some sort of latency on that data from when the data is recorded to when the data is reported. I personally don't know how to know what the latency difference is between these different sources, but that's certainly something to take into account. But yeah, I certainly wouldn't recommend calibrating a model to the Google travel times. but it's certainly another data point. I would still recommend getting a more detailed set, since you don't really know any of the statistics behind the Google data, but it's certainly a nice archive and sort of gut check to have. All right. Well, thank you everybody for attending. We're a few minutes early here on ending. Hopefully this was an informative session. Who knows how much longer we'll be all working from home, and we'll be looking to do more SimCap events, whether they're in person or potentially have webinars. Feel free to email myself, Randy Johnson. You can email me at rsj@dksassociates.com, or you can click to our link on OregonITE.org. And if you have any suggestions for future events, feel free to send those in, or any follow-up questions. And again, we'll go ahead and see about getting this presentation posted online. So again, thank you. Have a good rest of your day.